Good morning students. Today we are going to discuss motion and time, 7th class IIT most important bits for exam. We have to know few formulas, that velocity is equals to displacement by time, where acceleration A is equals to final velocity minus initial velocity by time, and average velocity which is equals to total displacement by time, and average speed is equals to total distance by time. So by using these formulas we have to solve problems in motion and time. Here is the first bit. A ball is dropped freely from the top of the building. It will fall down with uniform acceleration. A ball is dropped from the building. While it's falling, its acceleration is uniform, which is equals to 9.8 meters per second square, which is called as gravitational energy of Earth. This is the second question. A stone is freely dropped from the top of the building. Then it has positive acceleration, initial velocity is 0 and velocity is gradually increasing. All the above options are right. Here it's having positive acceleration because it's falling towards Earth. So G value will be plus. If it is traveling opposite direction to the Earth, then its acceleration will be in negative, but it's falling, so its acceleration is positive, and initial velocity will be 0, as when we are dropping from some height, its initial velocity will be 0. This one is also right, and its velocity gradually increases. Its velocity is increasing from 0 to, so its velocity gradually increases. All the above will be right. This is the third problem. The numerical ratio of the displacement to distance. Numerical ratio means displacement by distance. We know that from a point A to B, this is the displacement, and this may be the distance, and this may be the distance. Then displacement is always small number, so which means displacement will be 1 and distance will be 2. Then we will get 0.5. So like this, for example, displacement must be small. If the numerator is small number, then automatically we can say that value will be in 0 point something, so which is less than. In some cases the displacement is equals to distance, so then 1 by 1, which is equals to 1. So the numerical ratio of displacement and distance is maybe less than 1 or equal to 1, maybe less than 1 or equal to 1. Option 4 is right. This is the next question. A car from rest, acceleration with 3 meters per second square. What is the velocity of the car after 1 minute? Have to use this formula. So here acceleration is given, A is equals to 3 meters per second square, and he is saying that car is starting from rest, so initial velocity Vi is 0, and we have to find final velocity of the car, and time is also given, which is 1 minute, which is equals to 60 seconds. So time is given 60 seconds. So we have to substitute all these in this formula. We get Vf. So 3 is equals to Vf, we don't know, Vf minus 0 by time is 60 seconds. So we send the 60 to that side. Here it is dividing, so when we send 60 to that side, it multiplies. 3 into 60 is equals to Vf minus 0. So finally Vf is equals to 6 3 is 18, 180. Here 180 meters per second is the velocity of the car. Now this is the next question. A body moving with constant velocity during a time interval 50 seconds. What is the acceleration? Here he is saying that constant velocity means final velocity is same equals to initial velocity. If we substitute here same value here and here, for example 20 minus 20, we will get 0. 0 by 50 seconds time, 50 seconds given, 0 by 50 which is equals to 0. So finally acceleration will be 0. For constant velocity, if the body is traveling with constant velocity, then acceleration will be 0. Acceleration is nothing but change in its velocity with respect to time. So acceleration will be 0. These are the next two problems. Here acceleration of the car is given, which is 2 meters per second. A is equals to 2 meters per second square. Its change in velocity in 10 seconds is asking change in velocity, asking Vf minus Vi is asking. So A is given, 2 is equals to Vf minus Vi by time is also given, which is 10 seconds. We need to find this Vf minus Vi, change in velocity. So we send this 10 to that side, this becomes 20. Vf minus Vi, which is change in velocity, is 20. And another problem is a body vertically thrown upward fell on earth. Its average acceleration during its entire journey is, if average acceleration means while it's thrown upward, a1 is the acceleration, and again it returns to ground on earth, acceleration is a2. Finally here when we thrown upward direction, it's having negative acceleration. When it's coming down, it's having positive acceleration. This a1 is equals to a2, but a1 is negative and a2 is positive. So finally a1 plus a2 by 2. Here a1 is negative minus a1 plus a2, both are same values but negative values, so we get 0 acceleration. Throughout the journey it's having average 0 acceleration. These are the most important problems. The velocity of the car changes from 54 km/h to 90 km/h in 2 minutes. Its acceleration we have to find. Here the velocities are given in km/h. We have to convert them into meters per second, from km/h to meters per second. For converting km/h to meters per second, we have to multiply with 5 by 18. For converting meters per second to km/h, we have to multiply with 18 by 5. So we have to remember this. From kilometers is a big unit, so we are converting into meters per second. So meters per second is a small unit, so we have to multiply with 5 by 18. 5 is the small number, meters is also small number. Here we are converting from small units meters per second to kilometers per hour, big unit. So big unit, so we have to place big number 18 by 5. 18 by 5, 5 by 18 is a constant. We have to remember for conversions. First we will convert 54 kilometers, we have to converting into meters per second, so we multiply with 18 by 5 by, we multiply with 5 by 18. So we know 18th table, 18 ones are 18, 3s are 5, 3s are 15 meters per second. This is the initial velocity Vi, and where final velocity Vf is equals to, which is also given in kilometers per hour. We are converting 90 into 5 by 18. So as we know that 18 5s are 5, 18 1s are 18 5s are 5 5s are 25 meters per second is the final velocity. Finally we have to find out acceleration. So acceleration, which is equals to Vf minus Vi. We have Vf 25 minus 15 by, and time is 120 seconds. So here 2 minutes is given, so time is 120 seconds. So finally 25 minus 15, 10 by 12, 120, 0 cancel, 1 by 12. This is our answer. So here next question is convert 54 kilometers to meters per second. We are done here. We have converted 54 kilometers into meters per second, which is equals to 15 meters per second. And we have to convert here 72 kilometers per hour to meters per second. So we are converting from big unit kilometers per hour to small unit meters per second. So we have to multiply here 72 into small unit, so small value will be come in numerator. 5 by 18. 18 ones are 18 fours are 4 5s are 20. 20 meters per second. This is our next problem. A body moving with velocity 5 meters per second. Its velocity is given. After 5 minutes is 20 meters per second. Here initial velocity of the body is given, which is Vi is equals to 5 meters per second, and after time 5 minutes 300 seconds, which is equals to 300 seconds, its velocity is now 20 meters per second, which is final velocity. We have to find acceleration. We know that formula. Here is our formula. A is equals to Vf minus Vi by t. So Vf is 20, Vi is 5, and time is 300 seconds. So finally 15 by 300. So when we solve, 5 ones are 15 ones are 15 2s are 30, so 20 is 1 by 20. So 0.02 meters per second square is the answer. So here we have to convert next question. 15 meters per second to kilometers per hour. This is the big unit when compared to this. So we have to multiply it 18 by 5. In numerator we have to write 18. 18 by 5 into 15. 5 ones are 5 threes are, and finally we get 18 threes are 54. 54 is the answer. Now these are the last two problems we have to discuss. Converting 54 kilometers per hour to meters per second. So we will multiply 54 into meters per second. So 5 by 18. 18 ones are 18, 3s are 3 5s are 15. 15 meters per second. This is our option. And finally this is the last question. A person moved 100 meters straight. The person is here. He moved in a straight he moved in a straight 100 meters now here, and again returned back on a straight line 70 meters. He returned back here in opposite direction 70 meters. So what is the distance and displacement from this point to this point? He traveled from A to B and returned to C. So here distance is the total distance to reach C. He traveled 100 and returned 70. So distance becomes 100 plus 70, 170. So again displacement is the shortest distance. So if he want to reach C, he may have traveled just 30 meters. 100 minus 70, 30 meters. So displacement is 30. Finally, these are the most important models of problems you have to practice.